beautiful people, and welcome. In this video, we're going to be talking about how to add and subtract rational expressions. Now, rationals are simply fractions, so think whenever you see the word rational, think fractions. Now, whole numbers are also fractions. Keep that in mind. As always, disclaimer time, if I make a mistake, I am human. Just let me know where the mistake occurs so that way I may learn from it. All right, so the first thing I'm going to go over is the steps. Then we're going to take those steps and apply them to an example that we're going to do together. So the first thing you're going to do is, again, rationals think fractions. We are adding and subtracting fractions, just like you would add and subtract fractions in middle school and grade school. You are going to add and subtract these rational expressions, but this time you're going to have polynomials in the numerator and polynomials in the denominator. So the first thing you're going to do is you're going to factor all denominators. So sometimes you're going to be adding 2 terms together, 3 terms, or subtracting. You're going to convert all of those denominators into factors. So you're going to factor denominators. Step number 2 is you're going to convert to common denominators. So just like when you were adding and subtracting regular fractions, you're going to convert the denominators to like denominators. Find the least common denominator, the LCD. You're going to multiply everything in top and bottom, and you're going to ask yourself, what is missing from each denominator? You're going to keep the denominator in factored form. So once you factor it, you're going to make the denominators the same and keep the denominator factored. Number 3, if subtracting, you're going to convert to adding a negative. So you're going to distribute that negative, step number 4, and you're going to add those two fractions together. Now, when you are adding fractions, you are adding the numerators together, combining the like terms. The denominators stay the same. So you do not add the denominators. You've created like denominators. You're adding the numerators. You're combining like terms in the numerator. However, you are not combining the denominators. Step number 6 is factor and simplify if possible. So here's our little arrow here, and it says note excluded values in the denominator. Excluded values are x values that make each bubble 0. So we are still finding those roots, those zeros, and we're stating things that x cannot be. Because we have factors in the denominator, those factors cannot equal 0. Those bubbles cannot equal 0 because then we would have a 0 in the denominator, and we cannot have zeros in the denominator because then the world explodes. So we want to let the reader know, saying, hey, we have this fraction. However, because we have a variable in the denominator, that variable x cannot be these certain values, because if x is those values, or if x are those values, then it will make the denominator 0 and the world explodes. Okay, I hopefully have covered all these steps. If there are more steps, definitely we can go back and add those steps. That way it will be a little bit more clarifying on how to do these problems. All right, let's start with something basic. Let's start with something that we're doing in grade school. So 3/5 minus 5/7. Now I'm going to do all of my steps. So here I'm reading through the steps. What I would recommend you guys is I would recommend you writing these steps out. So if you need to pause this video, copy all these steps down, and then that way you have something to refer to. So step number 1 is we're going to factor all denominators. Now I don't have anything to factor here and here because 5 and 7 are both prime. Now if I had a different denominator, let's say 6, then I could factor a 2 and a 3 out. But here we're going to go ahead and leave it as 5 and 7 because we cannot factor. And sometimes that will happen with your rational expressions as well. Sometimes the denominator is prime. So we have 5 and 7. Step number 2 is convert to common denominators. Multiply top and bottom. Find the least common denominator. So what you're sometimes going to see is you're going to see off to the side an LCD. Now that is your least common denominator. What is the smallest thing that 5 and 7 have that can 5 and 7 that can create to make that denominator? So what you're going to do is you're going to take everything. So I have a 5 here. You're going to have a 7. And you're going to ask yourself what is missing from each denominator. And what does that mean is if I look at 5, if I'm looking at 5 and be like, hey, what is missing? Well, if I have a 5, 7 is missing. And if I look at 7, and I ask myself that same question, what is missing? Well, if I'm looking at 7, 5 is missing. So for this fraction here, the 3/5, what is missing? 7. So I'm going to multiply top and bottom by 7 minus, and once again, here's my 5/7. What is missing from that denominator? From that denominator, I'm going to just write this in a darker color. And from that denominator, 5 is missing. So now we're going to keep the denominator in factored form. So I have 3 times 7, which is 21. I'm going to keep the denominator in factored form minus 5 times 5 is 25. Keep the denominator in factored form. Okay, so now we have 21. Oh, you guys, I almost skipped number 3. Number 3 says if subtracting, convert to adding a negative. So we're going to convert this to adding a negative. So I'm going to distribute this negative here, and I'm going to make this addition. So that means I have 21 plus a negative 25. And then I have 5 times 7. So 21 minus 25, that is a negative 4. 5 times 7. Now, the reason we are keeping the denominator in factored form is because sometimes after you have simplified your numerator, things can cancel out. So if you already have the denominator in factored form, it's easier to see if there's any bubbles that are identical that you can cancel out. In this case, I have a negative 4 in the numerator. I have a 5 and a 7 in the denominator. My bubbles do not match. So in order for you to cancel anything out, your bubbles have to be identical. 4, 5, and 7 are completely different bubbles. Therefore, I cannot simplify this expression. Now, because this is just integers, we can continue and say this is negative 4/35. However, when we're dealing with these rational expressions, you're actually going to want to leave your answer with the denominator factors. It's going to be easier for you because you don't have to expand the denominator. It's also helps you see if there's anything that you can cancel out. All right, let's go ahead and jump to example number 2. So here we have example number 2, and I went ahead and circled your x cubed and your x squared so they can kind of be in bubbles the same. Our step number 1 is to factor all denominators. So I highlighted the denominators as well. So when you are looking at the denominators, how do you know something is factored or is in expanded form? So if you see bubbles, if you see parentheses, that means it is in factored form. If you do not see parentheses, that means it is in expanded form. Now, if it is in expanded form, you have to factor both the denominators. If it is in factored form, that kind of helps you out because then you get to skip step number 1, which is to factor, which if it's already factored, you're done. So step number 2 is to convert to common denominators. Multiply top and bottom by finding the least common denominator. You're going to ask yourself what is missing from each denominator. And we want the denominator after we've converted to like denominators to be in factored form or to remain in factored form. So here I have my LCD. Now, what is the LCD? That is the least common denominator or lowest common denominator. So the way that you're going to create this LCD is this LCD will represent your common denominator. Common denominator. And the way that you're going to do it, so you're already factored, you're going to look at each bubble. So all the different bubbles get their own space in the LCD. For example, I have an X, so I know I'm going to have an X in my LCD. That is one bubble. Now, there's an X cubed and an X squared. That just means the quantity of X is different, but I still have my main bubble being X. Now, my secondary bubble that I have is X plus 1. Now, again, the exponent is different, meaning the quantity of my X plus 1 is different. So what is the lowest common denominator? What is the denominator that we can get to? Now, I can't really take away an exponent. Like here, I can't really take away an x. That would be weird. So we're going to say, here is my x cubed versus x squared. I know that I can get to an x cubed if we multiply by another x. So my lowest common denominator that I can get to is x cubed. Now we're looking here, and that is I have an x to the first power and an x to the fourth power. How do I get there? Well, I need my x to the fourth power. So that is going to be, excuse me, I don't know why my phone is going off. So that is going to be your lowest common denominator. That's going to be your denominator for both fractions. Now, how do we get there? If that's the LCD, how do we get there? So let's go ahead and ask ourselves that question. What is missing from each denominator? So if I look at this denominator first and I look at my LCD, what is missing? So I have an x cubed and I have an x plus 1 to the first power. What is missing? Well, I have an x cubed already. That I have. What is missing is my x plus 1 to the fourth power. Now I do have an x plus 1 to the first power. So what is missing? What is missing is 3 of those. X cubed times x plus 1. And what is missing is I am missing my x plus 1. And how many are missing? 3 of them are missing. So I'm going to multiply top and bottom of that fraction with x plus 1 cubed, because when I do that, this will then give me my LCD, which is x cubed times x plus 1 to the fourth power. We're trying to get to our common denominator. So now let's add and do the same thing for our secondary fraction. We're going to ask ourselves what is missing in order to get to our LCD. So I'm looking here, and I have an x squared, x plus 1 to the fourth. Well, I have an x plus 1 to the fourth, so I don't need that. What I do need is an x cubed. How do I get to an x cubed? I'm going to multiply top and bottom by 1x. Because when I multiply top and bottom by 1x, that gives me my x cubed times x plus 1 to the fourth. Now, if you notice here, I made a hiccup. I multiplied top and bottom by x plus 1 cubed, but I didn't really multiply the top by that. So I'm going to go ahead and put that in. It's x plus 1 cubed. Here I have 13x times x. And so now that we have converted to a common denominators, if subtracting, we're in step number 3, if subtracting convert to adding a negative, which we don't have because we have addition. Step number 4 is distribute the negative to all terms. Doesn't apply here because we have a positive. Step number 5 is add numerators together, combining like terms. Now, here's the first thing that step number 5 did not tell us. It says add numerators together, combining like terms. So before doing that, we want to expand all bubbles. We want to expand all bubbles and then add the numerators together. So here I have an x plus 1 cubed, and I have so that's the only bubble. That's the only bubble that I need to expand. So what I'm going to have is I'm going to have 11 times x plus 1 times x plus 1 times x plus 1. Then I'm going to have plus 13x squared. I'm going to combine those. And that's all over my common denominator of x cubed times x plus 1 to the fourth power. Now you do want to you want to expand out these bubbles. Don't cancel out. Please do not cancel anything out. You cannot simplify unless you're on step number 6. Step number 5 is we have to expand all bubbles, add numerators together, combining like terms. Please do not cancel anything out. The reason being is this plus prohibits you from doing any simplifying from the denominator. Multiplication is king when you're doing this stuff. So unless you have multiplication only, you cannot simplify with the denominator that is factored. Don't do it. So let's go ahead and expand out this bubble, combine like terms. Now I will have to multiply this together a few times. So I'm going to do FOIL. So that's x squared plus 2x plus 1 and that's going to be multiplied by x plus 1. I'm going to do a quick box method here. If you want to just do FOIL, you can. I prefer the box method for things like this. It's just easier for me. So I have x cubed to x squared, x squared, to x, 1. Okay, so I'm going to bring it down here. So I have 11 times x cubed plus 3x squared plus 3x plus 1. And all of that is being added by 13x squared. Now keep in mind we still have that 11 on the outside of the bubble, so we're going to have to distribute that 11. So what do we have? We have 11x squared plus 33x. Oh, this should be a cubed, you guys. This should be a cubed. Let's change that to a cubed. 33x squared plus 33x plus 11 plus 13x squared. And we, again, keep the same denominator in factored form. Oh, I don't think that's going to be enough room, so I'm going to bring it down here. So what do we have? I am still combining like terms. I have plus 13x squared, and I have 33x squared. So what I have is 11x cubed plus 46x squared plus 33x plus 11. This is all over x cubed plus x plus 1 to the 4th power. Now, this is where you get to check if you can factor anything out from every single term. You cannot simplify from the denominator. The denominator is going to tell you that is going to tell you that things are factored. The numerator right now is not factored. So if you can factor something out, if you can undo that multiplication in the, what step is this? In the numerator, then we can cancel them out. I'm looking 11, 46, 33, and 11. I can't factor anything out because the 11 is prime. So we can only factor out 1 or 11. We can't factor out 11 from 46. So that means we are done. We can also try to do grouping since I have 4 terms, I can try grouping. However, again, I cannot pull anything out of this 46 and 11, and I can pull out something from 33 and 11. However, 11 and 46 doesn't work. So therefore, if you cannot factor, then you are done. Now, one thing that we didn't do is we didn't state our excluded values. So excluded values is in your factored form. You're looking at what zeros x will be to state what it can't be. We can't have the numerator, we can't have the denominator be 0. So if we have the denominator be 0, then the world explodes. And I say that, dramatically. You can't divide by a 0. So if x is 0 here, you're doing the exact same thing you were when you were identifying zeros in a polynomial for your x-intercepts. So if this right here, x cubed, that means in order for x cubed to be 0, it has to be 0. This is x plus 1 to the 4th, so this is -1. That means x cannot be 0 and x cannot be -1. If x is 0, that means I have 0 times anything, which is 0, gives me a denominator of 0. If I have -1 here, that means I have 0 times x cubed, which is again 0. We cannot have 0 in the denominator. All right, let's try example number 3. Step number 1 is factor all denominators. It looks like, remember, how do we know if the denominator is factored or not? We're looking at our bubbles. So I don't have any bubbles in the denominator. That means we need to factor. So I have 2x plus 1 in my numerator minus 3x minus 2 in my numerator. So what do I have in my denominator? So I have 3x squared. So I'm going to do quickly my slip and slide method. Two things that multiply to 24 but add up to -2. I am thinking 6 times 4. 6 times 4 is 24. but I need a negative and I need a negative 2, so I'm going to do x minus 6 and x plus 4, but that is not what we have. We have a 3 as our leading coefficient. So I have x minus 2 times 3x plus 4. So that is my factors. So I'm going to write that here, x minus 2 times 3x plus 4. And I'm going to do exactly the same thing for my other denominator. Since I have 3 terms, I'm just going to factor it. Again, it's x squared minus x plus, just getting minus 12. Two numbers that add up to negative 12. Excuse me, two numbers that multiply to negative 12 but give me a negative 1. I'm thinking negative 4 and positive 3. Dividing by 2, since that is my leading coefficient. So I have x minus 2 times x plus 3/2, which means that my new coefficient is 2. Ooh, that should be a negative. Taking those two things, I'm writing it in my denominator as a factored denominator. So these are my two factored denominators. Now, step number 2 is to convert to a common denominator. So you're going to create that LCD. Do you really need to create that LCD and like write it out? You can if you want to. Usually what I do is I just ask myself what is missing. So for example, my LCD is what every single different bubble you're going to write down. You're going to write down the highest quantity of that bubble. So for example, I have an x minus 2 bubble, and the highest quantity of that is with an exponent of 1. I have an x3x plus 4 bubble, and with the highest quantity of 1, and I have a 2x plus 3 bubble. So this is going to be my factored denominator, my factored common denominator. So you're asking yourself what is missing. This is what I do. I don't like to write out the LCD. I ask myself immediately what is missing, and I multiply top and bottom by that. So if I'm looking at my other denominator, so what I'm doing is I'm looking here. I know that I have an x minus 2 in both. I have an x, I keep saying x minus 2 in both. I have a 3x plus 4 in this denominator. I don't have it in this denominator. However, I'm asking myself, what is missing? What is missing here? I don't know if you guys can hear that, but they're apparently wind blowing my door and my window. You can hear that. I apologize. Very loud. Okay. So what is missing from this bubble here? I am missing a 2x plus 3. So that's what I'm going to multiply by. Whatever is missing, I'm going to multiply by that. I am subtracting 3x minus 2. And then here's my denominator. And now I'm going to be asking the other question. Here's what I have in this denominator. What is missing? And I'm looking into this denominator, this first denominator, and I'm asking what is missing. And I'm looking, I have my x minus 2. I don't have a 3x plus 4 in my denominator. So I'm going to multiply by 3x plus 4 in order to get what I need to get to my LCD. So when you're multiplying this out, again, don't multiply the denominator out, just the numerators. My denominators stay as x minus 2, 3x plus 4, 2x plus 3, minus, and then we have our 3x minus 2 times 3x plus 4, and that is divided by x minus 2, 2x plus 3, and 3x plus 4. So now that we have common denominator, so all the bubbles in the denominator match with the same quantity, meaning the exponent is the same, we need to go to step number 3. And step number 3 says, if we are subtracting, convert to adding a negative. So here's my negative. So that means here's my subtraction. So we need to convert that to adding a negative. So what you're going to do is you're going to distribute that negative. Now you're not going to distribute that negative here. You're going to distribute that negative here. So what we can do is right here where it says subtracting, convert to adding a negative. So we're going to do these steps. So distribute before finding common denominator. So we would, and again, we're generating these steps. So we want to distribute before finding the common denominator. The reason is I don't want to distribute that negative to my 3x plus 4 because that's not a negative bubble. This is a negative bubble. So what I would do is I would take this minus, convert it to a plus, and then distribute that negative here. So what I would really have is I would have a plus, I would have a negative 3x, and a positive 2. Notice that my 3x plus 4 bubble does not change. So let's go ahead and multiply everything out, expand everything out. So I'm doing FOIL in my head. So I have, what is that? 4x squared. 2x plus 3 is 6x. I have 1 times 2x, that is 2x, and 1 times 3, that is 3. I'm going to add that, and now I'm distributing or foiling out these terms. So I have negative 3x times 3, that is negative 9x. Then I have a negative 12x. Then I have a positive 6x, and I have a positive 8. All of that is over our common denominator in factored form, which is x minus 2, 3x plus 4, and 2x plus 3. Combine like terms and simplify. So what do we have? Let's see if we have anything. Oh, I do have something. Oh, you know what? This should be a squared. Hopefully you caught that. So I have a negative 9 squared, and I have 4x squared. So that would give me 4, 5, 6, 7, 8, 9, negative 5x squared. So those go away. I have a positive 6x, positive 2x. So that's an 8x. I have a negative 12 and a positive 6. That means I have a negative 6x. Negative 6x and a positive 8x. That combines to a positive 2x. Then I have a plus 3 and a plus 8. So 8, 9, 10, 11 here. And again, our denominators stay the same in factored form. That doesn't change. Here we have to check if you can factor. If you can factor, do so for the numerator. If you can't, don't. Now, here's the thing. Before you factor the numerator and simplify, you have to identify what your zeros are. So your zeros can be identified at any moment before you start simplifying your denominators. If you wanted to do it here right after you found the common denominator, you can. If you want to do it here right before you start simplifying, you can. And again, what you're doing is you're asking yourself, what does x have to be in order for that bubble to be 0? So in your head, you're doing x minus 2 is equal to 0, 3x plus 4 is equal to 0, and 2x plus 3 is equal to 0. That will tell you what x cannot be. You're solving for x, but you don't want zeros. You're saying, hey, this will make the denominator 0 if x is this value. So x cannot be 2. X cannot be negative 4/3. And x cannot be negative 3/2. If x is any of those 3 values, it will make the denominator 0. And we can't have denominator 0. So let's do a quick check if we can factor this numerator. I don't think so, but let's check. I'm going to do the slip and slide. Here's my thinking bubble. So I have negative 5x squared plus 2x plus 11. So I have x squared plus 2x minus, what do we have, 55. So two numbers that add up to positive 2 and multiply to a negative 55. I'm thinking 11 and 5 is 55, and that's the only thing that will give me 55. But 11 and 5 do not give me 2, so therefore this is prime, and you cannot factor further. So therefore, this is your final answer with the excluded values. All right, beautiful people, we will do lots more practice in class, as always. If you caught a mistake, I apologize. Just let me know where it is, and I will correct it. I hope you enjoyed this video, and I will see you in my next one. Bye!